Alrighty, welcome everyone to our webinar today where we will be looking at using exSILentia Cyber to complete cybersecurity risk assessment. My name is Patrick O'Brien and I will be presenting the webinar today. This webinar is using the GoToWebinar application, and so please make sure that you have your speaker enabled in all places to make sure that you're getting the audio. If you do lose the audio at any point throughout the presentation, please use the questions tool to the right of your screen to let us know, and we can help you troubleshoot and go through any technical issues. Also, if you have any questions throughout the presentation, either questions on the tool or technical questions on the methodology and cybersecurity risk assessment in general, please don't hesitate to put those in the chat throughout the presentation. Based on the timing for this morning, we should have around 10 minutes at the end of the webinar to go through and address any of those questions. For our topic today, we're going to be looking at using the exSILentia Cyber software tool to complete cybersecurity risk assessments and looking at how we can complete risk assessments that are consistent with the ISA IEC 62443 3-2 standard. And so we'll start by looking at the development and really the evolution of the exSILentia Cyber tool, where it came from, what really went into the specification of it. Then we'll go through a brief overview of what modules and what pieces are included. And then for the last half hour or so, I'll move over and actually demo the tool so you can see how the information moves in the tool, and I can show some examples of entering scenarios. And so again, if you have questions at any point through those different steps, please don't hesitate to put them in the question tool. Before starting, I like to give just a little bit of background on myself. My name is Patrick O'Brien, and I am a senior safety and cybersecurity engineer at exida. I've been at exida for a little bit over 8 years now, and my background is in chemical engineering. So really started out on the functional and process safety side, leading process hazard analysis, doing cell verification activities. And over time, we really saw more and more questions being asked about cyber, more potential cyber causes that could lead to significant impacts, similar to what we saw in our typical PHAs. And so my role really started to transition, where I now spend a large portion of my time really focusing on those cybersecurity activities. And as part of that, I was involved in the specification of the exSILentia Cyber tool. What features do we need to include? How should we set up the workflow? And I also helped develop the exida cybersecurity book implementing IEC 62443, a pragmatic approach to cybersecurity, as well as the relatively new CCPS concept book that came out in 2022 for managing cybersecurity in the process industry, a risk-based approach. And so before jumping into the content, I also like to give just a brief overview on exida. And so there are really three main areas in which exida works. We were founded back in 2000 as a certification and assessment body, focusing mainly on functional safety and the IEC 61508 standard. But over the years, we've really seen that group and the focus grow to include machine safety, automotive safety, and now, for the last 10 plus years, industrial cybersecurity as well. So we provide certification to product systems, personnel, to the IEC 62443 standard and standard series. We also have our Lifecycle services group, which is where we work directly with the asset owners and end users to do things like cybersecurity risk assessment, cybersecurity program development. And we also have a full lifecycle set of services for functional safety and alarm management as well. Again, tackling those toughest questions for the users. And then lastly, we have our enterprise tools group, which is responsible for the exSILentia software platform, as well as the OEMX platform. And so for exSILentia, which we'll be talking more about in today's presentation, there are software modules for the full functional safety lifecycle from PHA through SRS cell verification proof test generation. We have the SIL alarm tool, which is part of exSILentia Alarm. And then we've got our cybersecurity modules, which are a part of exSILentia Cyber. And so for our presentation today, we'll really be focusing on understanding that exSILentia Cyber tool and looking at how we can use that to complete cybersecurity risk assessments. And again, we'll go through that journey of really where we saw that development come from. And so as we get started and look at the material, this really all started when exida began to get heavily involved in doing cybersecurity risk assessments. And although the ISA IEC 62443 standard part 3-2 wasn't officially published until 2020, there had been much earlier draft versions of it, and some companies as far back as the early 2010s were really starting to look at doing cybersecurity risk assessments, trying to understand how we would model those considerations and understand the potential impacts to industrial facilities. And so when we looked at what was available, what was there, existing IT risk assessment tools were not really optimized to handle the same level of detail or the same granularity as the risk assessments for ICS systems. In a traditional IT risk assessment, they might look at the entire process control network or the entire ICS network as really one system and have one loss of availability or one loss of data confidentiality consequence for all of those systems grouped together. Whereas for a really ICS-focused risk assessment, you may need to look at each individual BPCS loop or each individual controller and component and really understand what could go wrong for that component. And so we saw that those existing IT risk assessment tools didn't really give us what we needed to follow that robust approach. And then looking at the traditional process hazard analysis tools that were out there, they had a more similar workflow, but again, they weren't really designed with security applications in mind, and they didn't help us get through that process as efficiently as we would like. They didn't fully line up with that 3-2 approach. And so as a result of this, when we were doing those early cybersecurity risk assessments, we were seeing that it was taking a significant amount of time, both for the assessments that we were facilitating, as well as the assessments that our customers were doing to really get that full study. And so we saw that this was an area where we needed something more. We needed a tool that could really help get that process done more effectively and efficiently. And so that journey that we went through on the cybersecurity side really modeled what we saw as a whole for the evolution of exSILentia in general. And so exida was founded back in 2000 as that certification group, but as we went through and were doing our SIL verification activities and helping doing that functional safety analysis, we saw that there wasn't really a good tool out there to make sure we got accurate, correct, and consistent results. And so we ended up developing that tool internally, using it for our projects. And then we saw that our customers actually needed that tool as well. And so that became Silver, which was first released in 2001. Over time, we added additional modules, additional functionality, until in 2005, we released the first edition of exSILentia, and we continued to grow, continued to develop that tool until releasing exSILentia 4 in 2017, which included that full lifecycle capability all the way from PHA through SIL verification to proof test generation, looking at the operations and maintenance phase. And so in that time period where we were working on developing and releasing exSILentia 4, there were significant updates to the PHA module, and we started to look at what really went into and what was involved in the exSILentia or the cybersecurity risk assessment, and what needed to be done to line up with the drafts of IEC 62443-2, what needed to be done with the different industry best practices and the methodologies that were being developed at that time. And we saw an opportunity to really leverage that and develop a cybersecurity specific risk assessment tool. And so in 2018, we released the first edition of exSILentia Cyber, as well as the exida cybersecurity book that outlined our methodology and our approach for doing cybersecurity risk assessment. And so as I was going and preparing for this webinar, I realized that we've already hit the 5-year anniversary of exSILentia Cyber, and I will say certainly does not feel like it has been 5 years since we first looked at specifying it. But looking back, there have been many projects since then, and we continue to really develop and evolve the tool over time, and picked up some really nice enhancements that make it even easier to use and really help going through larger projects. And so I want to start by just giving a quick overview on the thought process behind exSILentia as a whole, and then look at how that applies to the cybersecurity aspect. And so for each module within exSILentia, the idea and the approach is to make sure that that module can be standalone, and for that portion of the lifecycle that it is a best-in-class tool, that it makes sure that we are in compliance with the current industry standards, such as IEC 62443-3-2 for cybersecurity risk assessment. We can embed in additional industry best practices, so additional guidelines on how to complete the steps to align with the standard, ways to do it more effectively, more efficiently. We also look at making sure that we can generate a complete documentation of the work process. So for our cyber risk assessment, we need to be able to automatically generate reports that have, who attended which sessions, what were the recommendations, what are the results of the risk assessment, all of that packaged neatly into a single Word report, as well as getting the information we need in different Excel exports as well. And so that's our thought process for each of the individual modules. And then when we look at the platform as a whole, the idea is through intelligent lifecycle integration, we can make both the safety and security activities flow more effectively. And so between our CyberFacts and our CyberSL modules, we're able to flow that data forward, eliminate duplicate data entry so that we don't have to define a countermeasure in multiple places. We can define it once, link it to the scenarios where it applies, and then as we fill out information, that information for the countermeasure will follow us throughout the life cycle. What's also nice is the intelligent data core within exSILentia captures all of the threat scenarios, all of the countermeasures or protections we identify in the central library, and that can help us capture and institutionalize corporate knowledge. And this is something that, as we've done more and more risk assessments, we've found it to be very helpful because oftentimes, even if an organization has a few members who are very familiar with the standard, very familiar with the process, there are a lot more people who are trying to learn and get up to speed. And so as we do more risk assessments, as we can capture more of that expert insight, it makes it easier for the rest of the team members to complete additional risk assessments and really learn about that risk assessment process. And then lastly, we can look at the enterprise leverage from the intelligent data core. And the way that everything is stored within exSILentia, it makes it very easy for us to import or export that data. So for all of our library pieces, we can import from Excel if we have a pre-existing list of countermeasures or protections that are in place that we want to use and reference within our assessment. We can easily import that. We can export all of the worksheets into Excel for sharing with personnel who don't have access to the software themselves, so it's easier to sort and filter through the results. And there are a lot of additional configuration options to, again, leverage that core data that's stored within exSILentia for different applications. And so when we talk about exSILentia Cyber, this is really a collection of modules, and so there are 4 main pieces that are included. There is a cybersecurity checklist, which includes specific requirements from different portions of the IEC 62443 standard, as well as additional best practices that exida has identified. And so it provides a consistent place for documenting your, what compliance steps you're taking for those standards, as well as documenting any open actions or recommendations. We have our CHAZOP module, which is for doing control system hazard and operability studies. And we'll talk a little bit more about how that differs from a traditional PHA. And then we've got our CyberFacts and CyberSL modules, which are really the heart of doing the cybersecurity risk assessment in exSILentia. And that CyberFacts module can support both the both stages of the risk assessments in 62443, both that initial or high-level risk assessment, as it was originally called, and the detailed cybersecurity risk assessment. And then the CyberSL gives us a look forward at some of these semi-quantitative methodologies that are, I'll say, becoming more of a point of emphasis in thinking about taking a layered protection analysis-based approach and really applying that to cybersecurity. And so here for our cybersecurity checklist, we have just a simple example of one of the sections, but it gives us a consistent framework. It lets us save all of that information in the same place as our cyber risk assessment, and can be helpful for documenting that compliance journey with the different portions of the standard. We also have in the CHAZOP module customized guide words and node types that help us to more efficiently drive the assessment of those control system hazards. And so a CHAZOP follows a similar methodology to a traditional process hazard analysis or a traditional cyber risk assessment, but it is very much focused on the physical hardware failures or potential configuration failures that could lead to a control system failure. And so we've got different smart deviations, such as for basic process control system, looking at everything from loss of power to loss of comms or individual analog inputs or output failures, to really understand what the effect would be for that on the system, and how critical that may be. And so we can use that to easily drive through, document those worst cases, document our safeguards, and if we have cases where we have high remaining risk, we can then prioritize and make additional recommendations. And the reason that we include this in our cyber module is we've seen that a lot of companies, when they complete CHAZOP studies for the control system, they often include a cybersecurity element as well, because if we're thinking about all of the things that could lead to a failure of a control system, in today's day and age, if we're leaving out cybersecurity, we're really not doing a complete assessment. So this provides all of those modules, everything you need to do that full activity in a single place. And then for the CyberFacts module for cyber risk assessments, for the initial risk assessment, we focus on identifying just the worst case consequences and ranking how critical those would be, assuming a likelihood of 1. And really, we're just focusing on prioritizing the solutions, identifying which portions of our network architecture are the most critical zones. And so if we go through and identify that our BPCS network has a security level 3 target, let's say, based on the consequence severity, and our safety system also has a security level 3 target, we can identify those as really the focus for future studies to go through and look at in the detailed risk assessment. And then for our detailed risk assessment, again, we still use the CyberFacts module, but now we bring in additional variables, such as looking at specific threat scenarios, looking at the likelihood of certain types of attacks. And again, in some cases, organizations like to keep that at 1 to assume that the threat is present and focus more on the mitigations. In other methodologies, organizations like to estimate the relative likelihoods of attack. And so what we'll see is the exSILentia tool is actually very flexible, and really has the ability to support either type of methodology, and just help you go through that workflow more efficiently. We'll also look at the countermeasures or the protections that reduce the likelihood of a threat leading to a negative outcome, and we can estimate the likelihood with those protections to see whether or not we're meeting our risk goals. And so here's a screenshot example from the CyberFacts module, but we'll go through that much more in depth when we're in the tool. And then lastly, on our SL verification side, our CyberSL module is used to do that semi-quantitative consideration where we really look at trying to estimate the frequency we expect for cybersecurity attack, and to see how likely we believe that outcome is going to result. And so this is a place where we can automatically transfer the necessary data from the CyberFacts module into the CyberSL. We can look at how effective we believe the countermeasures will be and use this to start to quantify that residual risk. And we can also pull in additional variables here, and how many steps of the kill chain the attackers may need to get through, what level of target attractiveness we see for that specific site or that organization. And we can use this to get a semi-quantitative estimate of the likelihood. And I'll say that quantifying cybersecurity considerations continues to be a challenge. Certainly when industrial cyber risk assessments were first looked at, it really started as more of an arcane art of trying to understand and apply these complex concepts to industrial systems. And over time, we've seen that we're moving more in the process of quantifying it and turning it into more of a science. And the idea and the goal that I know several in the industry have said is for eventually that to evolve and turn into an engineering discipline. And I think as part of that journey, we're seeing more and more interest in this quantification. And I'll say that there is still much work to do to gather a robust set of data to really be able to point to these values. But as part of our work on developing the CCPS concept book, we did outline starting point estimates for countermeasure effectiveness and target attractiveness for common chemical sites to really look at taking a layer protection analysis based approach, or a LOPA approach, and applying it to cyber. And so this is something that we actually included as a module in the initial release of exSILentia Cyber, but it has not seen, I'll say, much use until recent years, where people really have started to dig in and want to understand that more quantitative aspect. And so that's our, I'll say the 1,000-foot view of the tool. But instead of talking through screenshots and slides, a lot of times it's easier to really jump into the tool and be able to walk through and show what's included. And so we start on the dashboard, which has a lot of helpful configuration options. We can also see each of the modules from our ChazOp to Cyber PHA and CyberSL. One thing that has changed since the first release of exSILentia Cyber is, although we still use it on the same exSILentia 4 platform, we now have different project types for functional safety studies, cybersecurity studies, and alarm management studies. And that was something that really helped to declutter the dashboard so that we didn't see 15 modules up at once. And it also helped to make sure that each type of project could run as efficiently as possible. So now for exSILentia Cyber, we'll just see these 3 modules in that cybersecurity project type. And so in the project information, we can define the basic things like the ID for the project, the name, the company. This is also where our cybersecurity checklist lives, so we can, again, flow through the different requirements, document our compliance argument, document any open items, and check whether or not we've completed that list. And so that's something that, again, can be helpful for supporting cyber audits as part of the risk assessment process. Then we can look at the project-specific configuration. And so for our nodes, these are the specific considerations for the ChazOp module, so we can identify the different types of control system nodes that we want to look at, whether it's for a basic process controller DCS system, whether it's for an SIS system. And these default deviations then become our smart guide words when we do the ChazOp studies and help to drive us through that activity. Similarly, on the cyber side, we can identify our different zone types for our zone and conduit. So we can think about using the Purdue reference model or the simplified ISA reference model that is looked at in the standards, or we can customize it if we have specific network or subzones that we want to look at. This is fully customizable, whether we want to do it by levels and have our level 4 business network as a specific thing that we're called out instead of enterprise. All of that is really fully customizable, is up to the user to configure it and modify if they want to change that from the base configuration. In addition to being able to specify our zones, we can also specify the individual cyber nodes. And here, we've seen over the years that the two most common methods of identifying nodes in the cyber assessment is to identify it based on the device type. So looking at the, let's say, specific threats and considerations associated with a controller, as opposed to, say, a Windows-based engineering workstation. And then the other method is to look at the specific threat vectors based on the threat agent. So based on whether it's a disgruntled internal employee versus an external nation state versus a less skilled external attacker, what sort of resources do they have at their disposal? What sort of attack pathways could they leverage? We have examples of nodes for both of those types. So here, one example being an external criminal. Personally, when I'm doing the risk assessments, I do really like the more equipment type based approach, because if we look at the broad areas of getting in through the people and social engineering, supply chain, thinking about communications disruption or man in the middle type attacks, and then the physical and hardware software considerations. If we cover those 6 main areas, we've really covered a broad range of threats, and we can dig into specific threat scenarios if we need to, but if they're not applicable, we don't need to take a lot of time to do that. And sometimes in the early days, I had seen companies come in with a list of 300 threat vectors that they wanted to use, and it just wasn't a really effective use of people's time in the risk assessment. So my recommendation is to use categories of threat vectors and then drill into those specific threat scenarios as needed based on the application. And so all of this, again, is fully customizable. If we want to take our engineering workstation as an example and create a new model for, say, an operator workstation instead, that can be adjusted. We can use copy-paste. We can identify additional threat vector scenarios and we review them. So say we want to, in addition to these threats that we've got called out, look specifically at, let's say vendor or third-party connections, if those are allowed for a component or not. That's something that we can, easily add. We can copy and paste each of these different levels within the tools to say we add that and say, hey, we want to look at the vendor or third party for the controller as well. That can be customized, can be updated. Another area where we can customize and configure the tool is the risk assessment matrix. And we do allow separate risk matrices for both the ChazOp tool and the cyber tool, or the cyber modules, if an organization has different cyber and different safety risk matrices that have to be considered. And so this is fully customizable. We can change everything from the colors to the risk levels to the likelihood levels and severity to make sure that it fully matches up with and is fully aligned with an organization's risk criteria. We also can identify an unlimited number of risk receptors or risk categories. So I know for cybersecurity, for example, a lot of organizations look at the reputational impact as well. In some cases, they may want to look at data security or data integrity based on some of the IT risk assessment considerations. So that can be supported from this tool as well. And we can identify our security level target either based on our severity levels or based on our risk. Again, the 3-2 standard really gives us and gives asset owners a flexibility for how to assign their target. And so the tool can support both of those approaches as well. And then before we leave the dashboard, I just want to highlight a couple of other key areas. So the first is team members. So here we can document everyone who was involved in attending the study. We can document the specific sessions that they were at, what type of session it was. We can include a description of what was covered on each date. And so those are big time savers when it comes to actually generating the report. So we don't have to go tracking to another source to see who was present on which day. We also have the library, which is a part of the intelligent data core that we talked about for exSILentia. And so everything that we create in the report or in the tool, whether it is a recommendation, a specific cyber threat scenario, or a countermeasure that we use, all of that is stored within the tool and can be linked and referenced for other scenarios within the project, or can be imported into other projects for use in the future. And so we have both export and import options into Excel. We can copy and paste between files. So there are a lot of, I'll say, really nice usability features that help cut down the time of the assessment. And then the last thing that I want to highlight here is we do have some starting point database information as a reference point, as a starting point, based on common countermeasures and estimated effectiveness. And these, again, are order of magnitude estimates based on our experience and the experience of customers that we've worked with. But again, certainly an area where we're going to see more development over time. But we do like to show this as it does provide you a starting point to go off of, and then see if you want to bring in other data sources, or you have your own user-specific data points that you use. That can also be configured within the tool and used as well. And so if we look at our Cyber PHA module, which is really where the cyber risk assessment begins, we can look through an example of both doing the high-level risk assessment and the detailed risk assessment. And so we've got some zoom options which can help with visibility depending on different screen sizes and making sure that everyone in the study can see. And we can go through and we can look at how critical the compromise of devices within each of our different architecture sections or our zones would be by documenting that worst case consequence, assuming a likelihood of 1, and seeing where that criticality falls. And so this can be used to support both of the, I'll say, common initial risk assessment methods that I've seen. So either an asset-based approach where you start with the network architecture and look at how critical each of those devices could be, as well as a PHA-driven approach where you're doing a security PHA review to identify whether or not a consequence could be caused by a cyber event. And in either case, if we look at our BPCS system, we can quickly move and input that information. So for example, if we're identifying a cyber PHA consequence or a PHA consequence that could be caused by cyber, we could insert consequence scenario from PHA. We can just simply copy and paste the text in. If we use our same risk matrix, we can identify exactly the same risk levels from the HAZOP and make sure that we have consistency there. And that will then make sure that we are ranking things the same way, whether we're looking at it in a safety or cyber risk assessment. If we have any sort of non-hackable protections that come into play, such as a pressure relief valve that we identify would be effective for that scenario, we could link that and look at the corresponding likelihood reduction. But those non-hackable protections are really the only ones that we would consider at the initial risk assessment or that high-level stage. Similarly, if we think about doing an asset-based risk assessment, and say we've gone through and looked at the potential for configuration changes to a BPCS controller, and we've identified what the worst case scenarios could be. As we go through and drive that assessment, if we see that the BPCS engineering workstation actually has the same impacts, we can quickly copy and paste those same scenarios, get the same rankings, and save time instead of having to re-enter or copy and paste each individual portion. And that, I'll say, is really what I've seen to be the biggest time saver when using a risk assessment tool as opposed to, say, working in Excel or even just marking up a zone and conduit on a PDF or a Visio file. So this really helps, get that information more quickly. And so for those areas in the high-level risk assessment where we identify that it is, let's say, a high security level target, a high risk for a potential compromise, then in our detailed risk assessment, we can really use the full zone, node, and threat vector hierarchy to look at each of the devices within a given critical zone. And so if we look at our BPCS controller and we want to take a look at, say, a stolen credentials attack where through a phishing campaign, attackers gain remote access to the system, we can think about, what devices would they be able to remotely connect to, what configuration changes can they make, and we can look at then that same consequence severity that comes from our high-level risk assessment, but now we want to think more about the specific threats or the specific pathways. And so that's where having our smart threat vectors defined and our typical threat scenarios that we want to look at defined helps us to really bring that through and follow that full cyber PHA process for doing the detailed risk assessment. And so we can go through, we can identify all of our countermeasures or protections that are in place. We can identify categories for them. We can identify how effective they would be, how much of a likelihood reduction we would expect to see from them. And then based on those existing countermeasures, we can select what the likelihood with the countermeasures would be. For this one, we started at a high likelihood, but based on the number of countermeasures that we have, based on the types of countermeasures, we can identify whether we want to drop that likelihood to a medium or a low. And depending on that likelihood, then it'll automatically calculate our risk based on our risk matrix for us. And we can easily delete countermeasures if they don't apply to a given threat scenario. We can link them where they apply. So say we wanted to link that new pressure relief device that we added in the HLRA, we can link that to the scenarios that applies. We can remove the non-applicable safeguards easily. And that helps us to just, again, save time when we have many countermeasures we need to look at. If we go through and even with our existing countermeasures, our risk is still high or medium, we can then make recommendations in the tool and link them to the specific scenarios that they're based on, so that when we generate our recommendations, we have that full context of what scenarios we're trying to mitigate and what risks we're trying to reduce by implementing those recommendations. And then the last piece that we can look at in the worksheet is we can also identify a cyber event scenario that would go to CyberSL. And this follows a similar process of linking a traditional PHA event to a LOPA, where we're identifying that, that specific threat scenario and those specific countermeasures should be evaluated in more detail in the CyberSL module. And so here, if we look at our IO point attack, we can evaluate this for multiple different risk receptors. And this, again, is where we get that view of the estimated likelihood of the different attack types, which countermeasures are in place, what target attractiveness we assume for the site. And so to really model out and estimate how likely we expect a given attack to be and whether or not that meets our target risk criteria. And so again, this is something where we don't have hard numbers. We don't have the data yet for cybersecurity incidents and the effectiveness of different protections to know for certainty that a firewall is good for 90% effectiveness or only 80% effectiveness or 50% effectiveness against different attack types. So these are really just order of magnitude estimates, but they provide a starting point for us if we try to get a comparison of how likely a negative cyber outcome may be compared to other, just hardware failures in the control system leading to process excursions or safety impacts. And it also gives us a line in the sand or a number where as we continue to track and gather data, we can see whether that number is looking accurate or can always adjust that lower or higher depending on what the data is showing. And so this is something that we just like to highlight as an option for organizations who do want to more quantitatively measure the risk. There are many organizations who still really want to focus on a qualitative cyber PHA approach. And that cyber PHA module gives you, everything you need to do that risk assessment to meet the requirements for the initial and detailed risk assessment of 3-2. But there are additional capabilities and features as well for those who are interested in it. And so once we go through and complete the study, we can then look at generating our reports and generating exports of the data information that we need. So whether we do a ChasOps study, a cyber PHA, or are doing a cyber SL, we have report options for each of them. We can specify what sections to include. We can identify what columns in the worksheet we want replicated to the report, and then use that to generate a report in Word. And so I have just a simple example for this file that I can pull up and show. So we've got simple cover information to go through and provide the background on the assessment. Looking at what are the sessions that were included. We can identify our references and actually link and store those within the tool. All of the risk information that we used in the assessment is outputted, as well as our recommendations. So for this one, we had quite a few recommendations, so we've got a long table there. And then we also include the full worksheet exports for exSILentia for both the high-level risk assessment, where we're really focusing on just the initial risk, assuming that likelihood of 1 and the worst-case consequence, as well as the full detailed risk assessment worksheet, where we can track everything through from the threat vector, the specific threat scenario considered, the consequence, and the specific countermeasures or protection for reducing the likelihood of that attack. And so this gives us that complete documentation from the assessment without having to spend a lot of time pulling out all of that information, like what were the recommendations, what is the resulting risk for the different systems. And so the report updates are another area where we really see the tool grow and improve over time. In the earlier days, we just had all of these worksheets on 7.5 by 11 pages that really were not, I'll say, sufficient to really include all of that information, or 8.5 by 11, I should say. And we've gone ahead and moved to 11 by 17, which really helps keep down the number of pages. I know I've had some that originally were 1,000 pages, and then with some tweaks and some improved formatting, came down to 200 or 300 pages. So still quite a lot of work that was done, but a lot more palatable and easy to go through. There are also export options to Excel, and so those we've seen become very popular for distributing the results to either personnel who don't have access to the exSILentia cyber tool or who aren't familiar with it and want to just be able to filter through the results more quickly in Excel, see which are the results that have high risk scores, and really focus on those. So that can all be exported to Excel as well, including the specific recommendations, specific cyber countermeasures. And so again, having that data core and being able to easily get information into and out of the tool is really important for helping and improving that workflow. And so that is a quick overview of the tool. And so if you have any questions or want to see specific capabilities or functionalities, please don't hesitate to put that in the chat. On the morning session, we had a couple specific questions and things that people wanted to see, so I'm happy to go through that, or answer any questions about the methodology and how that fits into the tool, or just experiences from cyber risk assessments I've worked on in general. And I'm just going to run through a couple quick outro slides for those interested in learning more or looking at cybersecurity training and things like that. Then we'll come back and go through those questions. So we do like to highlight the upcoming courses in the exida Academy, including the online self-paced options and upcoming live courses. And so we have a wide suite of online self-paced training, including a large number of functional safety courses. And then we also have alarm management, automotive, and cybersecurity courses as well. And if you are interested in learning more about facilitating and driving cybersecurity risk assessments, we do have the CS 101 and CS 102 courses that really go through a full IEC 62443 lifecycle approach for the asset owners or for those looking at managing systems, analyzing the risk, and mitigating that risk, as well as courses designed for original equipment manufacturers and system integrators. And then from our live course perspective, we do have a number of upcoming cybersecurity courses, and do just want to highlight that we're going to be running both halves, CS 101 and CS 102, in September as part of a live course that I'll be presenting on. And then if you enjoyed this presentation and are interested in learning more about exida and different upcoming webinars, please follow us on social media to get all of the updates and alerts for future webinars. Or if you have specific questions, don't hesitate to send me an email or review our website for more information. And so with that, I'll start to go through some of the questions that are coming in. Okay, so the first question that I see here is, if we have something like a PSV that was used in a HAZOP study to reduce the cell level, can we consider that in the cybersecurity risk assessment as well? And so for that question, yes, you are not limited to just using protection for a safety consideration versus a cyber consideration, because really those are separate causes of potentially the same consequence. So if the PSV is effective for that consequence and would still be effective in the cyber event, you can link it just like we showed for that example with the PSV for the cyber assessment as well. And that's not double counting or taking 2 credits for the same protection. Where we do want to make sure people are cautious and don't automatically assume they can take the same protection from the HAZOP is if there's a hackable protection such as safety instrumented system. If that is not independent, if that is not secured, you would not be able to look at that as an effective protection against a control system scenario leading to a loss of containment or a high pressure event. So you certainly want to make sure that the protection that you're bringing over is non-hackable. Okay, so I see a question here that is, what is the difference between your certification and the ISA IEC 62443 cybersecurity certificate program? So personnel certification, the main differences between a certification program and a certificate program is that a certificate program is focused on determining whether or not knowledge has been received from attending a course. So that was workforce concepts understood. And so that is an exam that comes directly after taking a course, and that course is mandatory to get the certificate. Whereas a certification program doesn't require any specific courses to be taken. It can be taken by someone who just has industry experience, but it does have experience requirements and credential requirements where, for example, for the certified automation cybersecurity expert, you need to have 10 years experience, whereas for the CACS, you only have 5 years of experience. So that would be something where that falls into play for the certification, and typically the exam questions tend to be maybe diving down to a little bit of a more rigorous level to assess that expert knowledge. So those are just some of the general differences between certification and certificate programs. But I know we have done some webinars focused on the exida personnel certification options. So if you are interested in learning more, certainly that is something that I can help point you toward. Okay, so this next question is, I see that likelihood credits are being used to achieve the security level target. How can we integrate this with IEC 62443-3 foundational requirements and respective of specific requirements to achieve the SLT levels instead of using the likelihood or tolerable frequency? And so this is a question I'll say that we are asking throughout the industry. I was on the 2-1 standards committee meeting, I want to say 2 weeks back, where we were looking at this question, and it's also being looked at in the new ISA site assessment and certification group. And so the idea is that, for 3-2, we look at security level targets from a risk-based perspective of how critical that risk is, whereas 3-3, it's really based on, are you meeting the foundational requirements, and do you meet specific system requirements and system capabilities? And so there's a little bit of a mismatch between the standards on how they look at security levels. And so in terms of, is there an industry approach that has been fully distilled and thought out and approved through the standards to really drive through that entire journey? I'll say it's something that is still being worked on. In terms of my personal perspective, which I'm always happy to provide, the way I see it is that from a risk assessment standpoint, we're really looking at how far we are from our current risk or our current situation to our target risk with the security level target. And so that could be something where if we go with a risk-based approach and we identify things that are read as security level 4, we can think about what do we need to do to meet security level 4 for those specific scenarios, where we may have others that are only security level 2 or security level 1. And so ultimately, whether we use certified systems or we demonstrate that we have the necessary system requirements to meet a given security level, or we choose to do it from a risk-based approach, it all comes down to demonstrating that capability. And so, for example, let me go in and pull up a specific scenario here. So let's say that in our cyber risk assessment, we identify that for our basic process control system, as a result of our consequence severity and our risk, that we've got a high target, say SL3 or SL4. When we think about this, a lot of manufacturers and OEMs are going and getting certified, and so they may be meeting the requirements for SL1 and SL2 primarily. But the number of systems that have gone through and really passed the requirements for SL3 and SL4 is still low, because there are significant changes and adjustments that are going in to meet those higher levels. So if you look at this and say, hey, I've got something that is needs a security level 3 or 4 target, and there are no devices that meet that, well, then you really are stuck from trying to go further. And so what I like to consider is using those foundational requirements that are in place as a basis, that those are going to be our starting protections to help drop that likelihood down to a certain level. But if we have gaps where the security level capability doesn't meet our target, then we can really go through and think about what they call compensating countermeasures in the group, and how we might use specific protections that maybe aren't required in 3-3 to get our risk for that system down to an appropriate level. And so I'll say that's something that the industry is still wrestling with to figure out the best way to do and standardize that workflow. But I see the opportunity of using compensating countermeasures as kind of bridging that gap between what the current capabilities might be for foundational requirements versus what the risk might be. And so that's something where, again, there are certainly different ways that we can do that and model that within the tool. We've got a lot of flexibility for what types of countermeasures we identify. I've seen some companies where when they look for defining the countermeasure categories, they actually line them up with the foundational requirements and system requirements. So they're linking protections from those specific areas to the scenarios where they reduce the risk. And that's another option or workflow for linking back 3-3 into our risk assessment process. Alrighty, excellent. So thank you very much for those questions. If there are any other questions that come up, don't hesitate to send me an email or connect on LinkedIn. I'm always happy to keep the discussion going. But thank you very much for your time, and we look forward to seeing you on another webinar in the future.